In this tutorial, you will design and build your own USB-C power supply. Once you finish this tutorial, you will know all the essential steps to design and build any board you like. You will also learn how to design a box for your board, and you will learn how to manufacture this box. In this tutorial, you will find everything important you need to know to start designing and building your own projects. Let's start. You don't have to install anything. We will design our board directly in browser using software called EasyEDA. Search for EasyEDA. Click here. Now register and log in. And we are going to use this Pro edition. It's free, so don't worry. I'm going to close this. File, new project. I'm going to call it USB-C power supply. Save. Now right click, rename. I'm going to call it USB-C power supply. And also I'm going to change the name of this. Again, USB-C power supply. And also I'm going to name the schematic page. Just call it schematic. Right click on PCB. And I rename this to just PCB. Save. Double click on schematic page. Now we are going to add title on our schematic page. Again, USB-C power supply, place. Leave it selected, and here we can adjust some parameters. I'm going to change color. You can use same color if you like it. And I'm going to change font and the size. Make it bold. And I'm going to center it like this. Okay, now I'm going to adjust some information in this table. So let's change the company name. I'm going to put here my name. Have a look what is going to change. And we don't want to have this and this, so I'm just going to switch it off. Save. Now go to JLC or LCSC parts. We are going to find connector, USB connector. And here find type C, 6 pins. This is simple one. In stock, apply. Order by availability. And I like it. This is exactly what we would like to use. So let's double check the datasheet. Rotate. Check the pins. So these are all the pins what we need. Perfect. Copy the part number, LCSC part number. Go to place, device. Switch to EasyEDA and paste. Press enter, search for the USB connector. They have it in stock and it's extended part. It means it's going to be a little bit more expensive for assembly, but it's fine. So we are going to place it inside of our schematic. Left click, right click. Left click to select it, and we would like to flip it. Okay, perfect. I'm going to move it a little bit. Okay. Now, I'm going to put here a node, so everyone knows this is the USB-C input. I'm going to change the font size and place it maybe like here. Go back to LCSC parts, we are going to find the connector which we will use for the output. So click here, find Phoenix contact, and use this one in stock, apply. I would like to use something like this. Okay. I like it. Okay, this is exactly what I would like to use. Copy LCSC part number, go to our schematic, place device, search for it. Place. Left click, right click. Okay, I'm going to copy this title and I'm going to change it to plus 5V output. Okay, perfect. Now, what next? Next, we would like to make some connections. So what I'm going to do, zoom in, press mouse wheel, and to draw connections, use this button, and just left click, left click, left click, right click, and left click. We would like to connect this to ground, so click here, select ground, and left click, right click, select it. I would like to hide the ground, so I'm going to disable it. And we would like to connect also the power. So let's do it this way. Select 5 volts, left click. In case you would like to change this voltage, just select it and you can change the name of the voltage here. Now copy this ground symbol and connect the shield. Press left button, hold it down, you can drag the symbol. Okay, we are going to connect these CCC pins. So search for USB-C CC pins table. Open this. Very interesting article. You can read it. And basically, this is the host side. This is the cable. And these are the resistors what you like to connect. Usually it's 5.1 kilo ohm. And based on the voltage on this RD resistor, you will know what kind of maximum current you can use. So for standard USB 0.5, when the voltage is here, then it's 1.5 amp, and when the voltage is between this, it's 3 amp. So CC pins are very important. Let's connect them. Place device, search in EasyEDA. Go and have a look inside of the resistors. Use this one. Okay, so select this. Now wait a little bit. It takes some time to load it. And we would like to use basic parts because these are cheaper to fit on your board. And we would like to use 0805. These are easy to solder, manually solder if you need to solder them manually. Search for 5.1 kilo ohm, it's this one. Apply filters. And okay, they have it. So they have it in stock and it's also a basic part. Click on place and just place the resistor inside of our schematic. Maybe like this, left click and left click, right click. Okay, connect the resistors. Just left click, right click, and also connect the other side of the resistors to ground. Okay, nice. Next, we would like to connect some capacitors. search in EasyEDA, and inside of the multi-layer ceramic capacitors, we would like to use basic part and footprint 0805, value, let's say 100 nanofarad. Apply filters. They have two. We can use this one for 50 volts because it's cheaper. They have it in stock, so we can place it inside of our schematic. Press spacebar to rotate and just place two of them. Copy, paste. You would like to connect them to ground. So this second one. Okay, and connect the other side of the capacitor to the power. So move this up and draw the connection. Move it a little bit so it looks nicer. And connect it. Okay. Now name these nets. So I'm going to call them like CC1 and CC2. We are going to connect this output. So we would like to use LED. Where is it? Here. So we would like to use LED because we would like to know there is voltage on the output. It's power on. So select the LEDs. Again, search for basic part. Bigger one, so it is easy to solder manually if you don't want to use the assembly service, because it's much cheaper to solder it manually. And find the green one. This is G, so this is green LED basic part. They have it in stock. Click on place and press spacebar to rotate. Be sure you place it correctly. Okay, it has to face this way. Connect the cathode to ground. And we have to connect the resistor for this LED. So again, place device in EasyEDA, search for resistors. Again, don't forget, use this one, okay? Not this one. This one. Left click. Basic part. 0805. And let's say we will use something like 1K resistor. I'm going to find it maybe 8K. Here it is. Apply filters. Okay, basic part is in stock. Place it inside of our schematic. Okay, make it nice. So I'm going to place it like here. Move this little bit and connect everything together. So this green LED is going to tell us we have 5 volts on output. Connect it to 5 volts and connect it to the output connector. I would like to have it in the middle. You can use arrows on keyboard to move selected components. Okay, move it a little bit up and connect this second pin to ground. Perfect. So this is like very simple connection. Maybe what we would like to make it a little bit nicer. Maybe what we would like to add is also a capacitor on the output. So I'm just going to copy it Notice how I'm going to do the selection, because that is different from top left. Everything inside of the rectangle will be selected, but from bottom right, everything what is inside and what is touching the rectangle will be selected. Okay, inside and what is touching. Okay, so I'm going to copy this and I'm going to place it here. Left click. Okay, make it a little bit nicer. Okay, I'm going to move it a little bit, so select it and use arrows on your keyboard and save everything. Same as here, we would like to maybe name this net, because if we don't name it, have a look, it's called like with this weird name. So what I'm going to do, I'm going to name the net. So left click and let's call it diode. Now when you select this net, you can see it's called diode. It's much nicer when you do PCB layout, you can very easily see what kind of net you are connecting. We would like to add mounting hole. So I'm going to create new component. This is also the way to show you how you can create your own components. I'm going to call it mounting hole 7.5 by 2.7 millimeter. 7.5 is the part size and 2.7 is the hole size. So be sure you are using correct grid and just place the pin. Watch the where the pin position is. It should be at 0, 0 position. I'm going to hide this pin name and I'm going to place a small circle so it looks like mounting hole. Okay. Or maybe not here, maybe like here. Okay. Make it a little bit smaller. We can adjust the parameters here. So I'm going to change this to 0.06. I'm going to fill it up with gray color, maybe a little bit lighter like this. And I'm going to change the width of the line like this. Okay, this looks like mounting hole. We can fill up all this information. We don't want to have the mounting holes in BOM, bill of material, because it's not really component. And I'm going to change this designator to MH question mark. Footprint, we would like to create footprint. So go and create new footprint. Again, I'm going to call it MH 7.5 by 2.7 millimeter. And footprint is the physical representation of this mounting hole in our PCB. So basically I'm going to place a pin into this footprint. And this is basically the mounting hole. We just need to adjust the size. So be sure we are using millimeters. I'm going to change the hole diameter to 2.7 millimeter. And I'm going to change the pad size to be 7.5 millimeter. Okay, so this is basically our mounting hole. Cool. When you select it, be sure it is multi-layer pad and the pin number 1. It needs to have pin number 1, okay, because that's what we use in the schematic symbol. Save it, go back to our schematic symbol, and now we can select the footprint what we have created. This one. Confirm, and now our symbol is linked to this footprint. I'm going to use this symbol or new component in our schematic. So go to Place, Devices, Personal Libraries, and this is our mounting hole. Place it inside of our schematic. Press spacebar to rotate. Okay, this looks okay. I'm going to copy this, and we need 4 mounting holes, so I'm going to place 4 of them here. 1 mounting hole in each corner of our board. I'm going to connect them to ground. So just copy the ground symbol, place it here. Maybe make it a little bit nicer. I'm going to move this and also this and this. Okay, it looks like it's in center. And add a note, copy this text and just change it to mounting holes. Cool. Perfect. I'm going to move this a little bit up. And maybe what we would like to do, we would like to add some information about this CC pin. So I'm going to copy this table or information from this table. I'm going to place it inside of our schematic. So CC1/CC2. Okay. And rename this. I'm going to change this to USB maximum current. Okay, we would like to draw a rectangle around this. Split this in the middle. It's not in the middle. I'm going to move this a little bit. Perfect. Now copy, paste, and I'm going to change this to 0.5 amps. This is the standard USB maximum current. What was the next one in the table? Do you remember? Next one was 1.5 amp, and the last one was 3 amps. So now let's have a look. Oops, I'm going to make this a little bit bigger. And also move this. Make the rows. So I'm going to place these lines. Just right click to cancel, left click, right click, left click, left click, right click. Okay. Let's go back to the table, and for maximum 0.5 amp, threshold is 0.66 volt. I'm going to copy this and paste it here. So if voltage on the CC1 or CC2 is between 0 up to 0.66 volt, the maximum current is 0.5. The next threshold is 1.23. So if the voltage is between 0.66 up to 1.23, the maximum current will be 1.5 amp. And if the voltage on CC pins, on one of the CC pins is about 1.23 volt, then maximum current is 3 amps. Very useful table. Save this. Now we would like to change these reference designators. So what I'm going to do, I'm going to reset them first. So use these annotate designators, clear designators, watch what's going to happen. Okay, so when I select this, confirm. Now all the designators, they have question marks. I'm going to manually name this one. I'm going to use J1, and this one is going to be J2. Because that's how I would like to have them on my PCB. And let's name all the other reference designators automatically. Watch what's going to happen. Perfect. Okay, so C1, C2, C3, and here are the mounting holes. Okay, I'm going to move this a little bit so it looks even nicer. And save. Before we go to PCB, we would like to change one setting. So be sure you enable this color silkscreen support for the PCB. Now in design, go to check DRC, and we would like to be sure there are no errors in our schematic. So you can clear everything and then check DRC again. There are no errors, no warnings. We are going to transfer our schematic to PCB. Okay, we would like to add all these components. Be sure this is checked. And this is our PCB. So save it. Use mouse wheel, zoom in, zoom out. We are going to place these mounting holes. Be sure we are using millimeters. Go to properties, change the grid to 5 millimeters. Go to filter, and we would like to work with components only. Okay, we are going to place mounting holes, place them exactly into same position as I'm placing them. Here is the position. Okay, so this is the second mounting hole, third mounting hole, and the fourth one. Fit the view. I'm going to change the grid size because I would like to place the components maybe like this. Oh, manually. You can place this connector manually into exactly same position as I'm placing this, and do exactly same for this one. Be sure it's facing out with these arrows, because that's the direction how the wires are placed inside of the connector. Okay, and this is how it looks. It's still a little bit weird because we didn't specify the shape of our board. So let's do it. Change the grid to 10 millimeters, so it's easier to draw the board shape, and just draw the rectangle like this. Okay, this is this size of our board. Be sure it's exactly the same. Maybe change the corners, and let's have a look. Cool, nice. Again, use mouse wheel or hold left button down to move in this 3D environment, or hold the middle button on the mouse and move the mouse. Save everything, and we are going to place the rest of the components. Here you can see where these components are connected, but we can go to schematic. In schematic, I'm going to select this capacitor. That's the first component what I would like to place. Now I'm holding the component, and you can just place it. Press left click. I changed the grid size to be a little bit more precise in the placement. Press spacebar to rotate the component and place it like here. Okay, this pin is connected to this component. Again, press spacebar to rotate, place it. This one, you can see very nicely where it is connected. And the next capacitor, I don't know which one it is, so I'm going to select it here in the schematic. Use this placement feature. I'm holding the selected component, and here it is. Now the LED and the resistor, you can select more components and use this feature. Left click to place it. Now press spacebar to rotate, place the LED, place the resistor for the LED. You can see how it is connected, okay? Watch the blue lines. And this is the last capacitor. Okay. Cool. This looks very nice. Close this. And let's continue. Next, we would like to do layout. We would like to connect everything. So go and search for JLCPCB capabilities. We would like to know what are the capabilities of the PC manufacturer, what we are going to use. So for rigid PCB, we would like to double check the minimum via hole size. And also we would like to double check what is the minimum track width and spacing, what we can use in our PCB. Okay, this is very important information. Go back to our PCB, design rules, load the default rules, and we are going to double check if they are okay. So select this one, and here they say minimum spacing for 2-layer PCB is 0.127 millimeter. Everything seems to be fine, just this first number is smaller, so I'm going to change it to 0.127. Now the track width, minimum track width is 0.127 millimeter, and here they specify minimum track width 0.127. That's okay. And let's have a look on vias. Minimum via, there are two parameters, the hole size 0.3 and path size 0.5. So inner layer 0.3 and 0.5. So this is okay. Perfect. Next, I'm going to hide these reference designators. Go to filter, and here hide the component designators. Watch what's going to happen. Now go back to property. Be sure grid size 0.5 millimeter, and be sure the top layer is active. That's the pencil. And we are going to draw on this top layer. We are going to draw the connection. Now, if you would like to learn more about how to set up correct rules or how to do proper component placement, how to route tracks, check out our online courses. We have courses in different software, in KiCad, Altium, Cadence. We have courses for beginners, for professionals about hardware design, PCB layout, EMC, measuring, and more. Just go to fedevel.com, you may find there something interesting for you. Now, let's go back to our board and let's continue. Use this button. I'm going to use 0.3 millimeter width for this track, and just left click, left click, left click. Okay. When you select this track, okay, go to filter, enable everything. When you select this track, you will see some properties of the track, and you can see the width of the track is 0.3 millimeter. Connect also this second CC pin. Okay. Now we would like to connect these pins to ground, and to do so, go on the bottom layer and place copper region. Okay, so we are going to place big copper on the bottom side of our PCB. We are going to connect this to ground, so be sure ground is selected and confirm. Right click, layer, go back on the top layer. Now we have ground on the bottom, we just need to connect this ground on the top with the bottom ground. So draw very short connection, and we are going to use via. Via will connect the top layer with the bottom layer. Select the track. For power tracks, I would like to use a little bit bigger tracks or wider tracks, so use 0.7, and also double check the size of the via. It should be like this. Okay, this is the default size of the via. I'm going to copy this, just left click, press Ctrl left click, copy, and left click in the middle of the path, because that's where we will hold the selection, and just paste all these connections on all the other components which are connected to ground. Spacebar to rotate, left click. Okay, maybe make this a little bit shorter, so just move this via and delete this. Okay. We would like to connect also these two grounds, so again, draw the track. Be sure we would like to use something wider, 0.7 millimeter, left click, maybe like here, left click, right click, place a via here, and place one more via. For power, you may want to use more vias sometimes. Select everything and copy and paste it on this second pin. Maybe I would like to move this via a little bit because it's kind of off the grid. So I will make it a little bit nicer. Press Ctrl, select these two vias, and change it to, I don't know, 4.3 millimeter. Okay, perfect. Draw the connection between the LED and the resistor. So this is the diode net. You can see this is the net which we named diode. Okay, and save everything. Now let's say we would like to swap these two pins. We would like to have ground here and plus 5 volt here. So go to schematic, and we are going to learn how to, make the changes in the schematic and then transfer these changes to PCB. So I'm going to disconnect this. I'm going to flip this connector. Watch what's going to happen. Okay, 1, 2, 2, 1, and I'm going to connect it again. Okay, so we made some changes in schematic. Now we would like to transfer these changes to PCB. I'm going to save this, design, update, schematic to PCB, and have a look. These are the changes what are going to happen. Okay, be sure this is selected. Watch what's going to happen in our PCB. Apply changes, and pins are updated. Now, when you zoom in, you can see this. There is still the ground connection from this polygon pore. It should not be connected together. So what we need to do, we need to rebuild this polygon. Okay, this is very important. You always have to rebuild polygons when there are some changes. So now it's disconnected, and now ground pin is connected. It's connected correctly. We would like to make it maybe a little bit wider. So go to design, rules, and here, select this. For multi-layer path, we would like to maybe use a little bit bigger distance between the path and the ground plane, and we would like to use the wider connection between the mounting hole and the ground plane. Zoom in, select it again. We would like to we need to rebuild this polygon. Watch what's going to happen. Now it's better. Okay. Next, we would like to connect the plus 5 volts. So place copper region polygon and draw it maybe like this. Okay, so this is the polygon which is going to connect all the plus 5 volt pins on the top layer. Just use mouse, left click, and draw this polygon around all the plus 5 volt pins like this. Okay, be sure the polygon is connected to plus 5 volt. So select it here, confirm. Okay. We need to make a couple of adjustments because I would like to make it a little bit nicer. First, change the grid size, make it a little bit smaller, 0.05. Now, notice when I hover cursor over this triangle, cursor shape is changing, and now I can move the edge of the polygon, okay? When you hold the cursor in the middle, then you can move the whole polygon, but that's not what we would like to do. Just hover cursor over this triangle when the cursor changes to hand, and just move the edges of the polygon. Make it a little bit nicer around the paths. Okay. And go back with the grid size. There is still something what I would like to change. This. I would like to make direct connection. Go to design, rules, select this, and for the single layer path, we would like to use direct connection. So there are no these, weird shapes. So don't forget, watch what's going to happen, rebuild the polygon, and now the paths are connected directly to the polygon. I don't like this. I would like to remove it. I don't like to route under components. Place prohibited region and draw it like this. Copper, confirm. Again, we need to rebuild the polygon, and okay, perfect. This is what you like to do. Same also here. So place the prohibited region also here. Same settings, rebuild, and perfect. Cool, this is exactly what I would like to have. Now, I would like to work with components only, and we are going to make it nicer. So first I'm going to hide designators for these mounting holes. And all the other designators, I'm going to move them a little bit. Maybe here. This is J1. I would like to work also with the components. So this is the C1. Now this is the R3, R2, and C2. LED, R1, C3, J2. I'm going to make it a little bit nicer, so change the grid size and use arrows on keyboard to move it a little bit. Okay, also make this nicer. Perfect. This. Okay. Maybe move also this a little bit. Okay. Save everything. We are going to add more information on our PCB. So on top silkscreen layer, we would like to add some text. And before we do so, I'm going to double check what is the minimum size of the text what we have on our PCB and compare this with the capabilities of JLCPCB. So minimum light width 0.153 and this one is 0.152 is okay. And height is minimum height is 1 millimeter and J1 height is 1.1. Okay, so we can use this. I'm going to copy this and I'm going to make this text same width. So just paste it here. And also I'm going to copy the height and I'm going to make our text same height. So I'm going to move this text to our connector. So this is basically, description of the connector is input. And I'm going to copy it and paste it. And I'm going to call this one out, like output. This is the output from our board. What else we would like to name? We would like to name the LED, for example. So I'm going to change this to power and I will change this to center bottom and I'm going to change this to LED. Again, the alignment, maybe we would like to do a little bit differently and name this LED power LED. So everyone knows this is the power LED. Maybe change the position a little bit, move it a little bit up. Okay, like this. No, like this. Cool. What else? Maybe I'm going to copy this. Maybe what we would like to do, we would like to tell everyone which is the positive and negative pin on the output. So I'm going to change this. I'm going to make it a little bit bigger. I'm going to move this plus sign to the plus pin of the connector, and I'm going to do exactly same with the negative or minus sign, and I'm going to move it down here. So this is the minus pin. Also, what we would like to do, maybe we would like to tell everyone this is our board. So I'm going to put here federal. Maybe make it a little bit nicer, like this. Move it here, maybe a little bit up. Like this. Okay. And also, of course, we would like to tell everyone our website, solvefederal.com. Of course, you can put the name of your company or your own name and link to your own website. Okay, nice. Save it. And let's add some information also on the bottom silkscreen layer. So I'm going to move this to bottom silkscreen. I'm going to change this to copyright 2024. Maybe make it a little bit different like this. Okay, go on the bottom layer. Maybe what we would like to do, we would like to change the view. So I'm going to flip the board. We would like to see the board from the bottom basically. So flip the board. Okay. And I'm going to put here also information about the board name and board version. So I'm going to call it for fun. This is the board name and the version of the board is going to be 1.0. Now I'm going to show you something cool. I'm going to place a logo here on the bottom side of our board. So if you'd like to place image, you can see there are actually many different formats supported. I'm using PNG, open. This is how it is going to look. I'm going to change the size of our logo. Okay, confirm. But I don't want to place it on the bottom layer. I would like to place it on the bottom solder mask layer. So what will happen? This will create nice gold logo on the bottom of our PCB. Okay, when we go to 3D view, this is how everything looks. It looks very, very nice. So close 3D view, save everything. And actually I noticed there's something. So go back to 3D view. I noticed this text goes on the path. Something is weird. So if you see something like this, just refresh the EasyEDA in your browser and it should fix the problem. So let's wait a little bit and open 3D view again. Oh, it's fixed. Okay, see now the text is correct. It doesn't go over the mounting hole. Okay, cool. Next, we are going to place nice color image on our PCB. So first, be sure you have the support for the color silkscreen enabled. Then place image, and I'm going to use this one. Again, it's just PNG file which I created. If you like to use the color silkscreen, you have to enable this. Okay, I'm going to change the size and I'm going to confirm this. So this is how you add very nice colored silkscreen on your PCB. Currently, when I'm doing this, it's only supported in China, but maybe when you will be watching this, it will be supported worldwide. So that's why I'm showing this. In 3D view, if you would like to see your board with the colored silkscreen, you have to use this option. And it looks really, really cool. I love it. It's very nice, beautiful. Okay. Next, we would like to learn how to create a box around our board. So place this 3D shell outline. Watch where I'm going to place it. So do it exactly the same way, like this. And I'm going to open also 3D preview so you can see what we are going to do it. You can see what we are doing actually. You will see the changes, what I will be doing. So I'm going to set it like this. Here you can move the top and bottom of the box. Again, just press left button on your mouse and move your mouse to rotate the view. Now, okay, I'm going to select the box here. Be sure filter is enabled. And this is what you can do. Watch. So this is different kind of box, but I would like to use this one. Here there is only one option. This one, I'm going to make it a little bit smaller. So I'm going to change it. So now the total height of the box is a little bit smaller. I'm going to move also this, and I'm going to change the height of the bottom part of the box. And this is the thickness. Okay, and this is the edge around the box. Watch what's going to happen. Okay, there is no edge, and when I change this, there is the edge. So, you know, top and bottom fits perfectly. So I would like to have it there. I'll leave everything else like this, and I'm going to add corners, maybe 3 millimeters, so it looks nicer. This is like super quick way how to create very simple box around your board. But we would like to make it better. Of course, we would like to make it much better. So we need to add some openings and then support for screws. So start with the opening for the connectors. We need to place this special line. Watch where I'm going to draw it. Draw it exactly at the same position. And this line specifies the edge or bottom of the enclosure of the box. And it will help us to specify where we would like to make the openings on the sides of the box. Okay. So I'm going to make this smaller. So again, you can see what I'm going to do. I'm going to place this slot. Okay, and watch what's going to happen. So this is the bottom of our box, and I'm going to create the opening. Okay, if I go back to the 3D view, here is the opening. See, when I move this, it moves. Okay, we just need to move the opening into right position. So you can use exactly same numbers what I'm using here. That's the size of the opening and the position of the opening. And when you have it, then it's exactly around the USB connector. Maybe I would like to round the corners, make it a little bit nicer. So I'm going to change this to 1 millimeter. I like it a lot. Okay, this doesn't have to go so deep into board, so I made it a little bit shorter. And we have to do same for the second connector. Okay, so again, place this somewhere here. I'm going to use the same size, 4 by 10 millimeters, and position is going to be like this. Okay, 55.5 and 20. This is the opening for the second connector. Here you can, hide some of the things, and I can see the connector is in collision with the box. You can see it. So we need to make some kind of adjustment in the box. You need to draw the same line as I'm drawing here. Use exactly the same numbers. Okay. So start position 30.6 and position 30.6, and again do exactly same as what I do. You will see a little bit later what we are doing. Okay, so this is the reference point. Make the square or rectangle 11 by 12 and place it like here. Now when we have a look on the box, you will see what we did. We created something like this. I'm going to make it a little bit smaller. So this will remove part of the enclosure which was in collision with the connector. You see it here, okay? Perfect. Now it's perfect. Okay. I'm going to save everything. And next, we are going to work with the top side of our enclosure. We would like to place holes on the top. And you do it this way, okay? It's super simple. Just select here, circle, and place it here. I'm going to use 2mm circle. When you have a look, there is the opening for the screw. Do it also for the second screw. Okay, again, super simple. And here it is. Oops. Maybe we can adjust the depth. I'm going to change this to 10. And perfect. We would like to see light from this LED when the board is inside of the box. So I'm going to do it a very special way. You can do it exactly the same way. So I'm going to add this something like a column or something. You will see when I finish how it looks. So be sure it's connected to the top lid, and be sure you use exactly same parameters. Okay, have a look what we created. It's like this, and now we would like to create a hole which will be just directly above the LED. Okay, so let's do it. Circle in the middle. I'll change this to 1, and okay, everything looks okay. And depth 13. This is important. Okay, put there 13, so it goes through the whole column, and now the LED is visible. See? Okay, so this is what we did. Later, when it's finished, what I will do, I will actually place transparent filament inside of this hole, and it very nicely will bring the green light at the top of the box. You will see it when it is finished. So this is exactly what I wanted to create. And you can see the hole is exactly above the LED. So this is perfect. We still need to add the support for the screws. So first I'm going to save this. And again, it's going to be super simple, so don't worry. I'm going to enable the bottom part of the box so we can nicely see what I'm doing. I'm going to use this special feature, place it here, and Right now it's not on the bottom part of our box, it's on the top part. So we have to select here, we would like to have it on the bottom. Okay. We need to adjust this a little bit. So first I'm going to change this to no. And I'm going to adjust the height, make it a little bit smaller, 4.9. Okay. Hole 2.7 and thickness 2 millimeters. Okay, we need also opening for the head, and yeah, this looks good. So what we can do, we can copy this. So I have to work with this filter a little bit. We would like to only work with this screw pillar, and I'm going to copy it and place it where all the 4 mounting holes are. Cool. And we have to add also this kind of support on the top part, or to the top part of our box. So let's do it. Again, first I'm going to save everything. Now I'm going to adjust the view. And we would like to work with this top part of our box only. Place it here. So this is how it looks. We need to make some adjustments. We don't need this. Okay. And we are going to use M2.5. So I'm going to adjust the height and also diameter for the hole. Thickness. Okay. Let's have a look. Okay, here it is. So this is what we created. It looks good. This is exactly what I would like to have. So be sure we only work with the top. Select this, copy it, right click, copy, and paste it above the mounting holes. Cool. So this is like super simple to create box around the PCB. That's why I wanted to show it in this tutorial. What we can do, we can add one more thing. Save this. We can add a plus and minus sign around these pins, so it's clear when the board is inside of the box. It's clear which one is plus and which one is minus. So I'm going to do it this way. You can do it exactly the same way. So I'm just going to place here small rectangle, 1 by 5 millimeters. Now it goes through the box, but we don't want to make it go through the box. So I will adjust the depth. Let's say we would like to use 16. So it looks like this. Okay, maybe adjust position a little bit. Okay. Okay, this is very simple way how we can write minus on the box. We will do exactly the same for the plus. So I'm going to copy it. This is okay. Okay. And copy and paste again. Change this to 5. This one is 1. And move it. Okay, let's have a look. This is exactly what I would like to have. This can be super useful, you know, everyone can clearly see where the plus and minus are. I'm just doing some double checking, so you can see the pillars are nicely touching the top of the PCB, so that's good. Okay, what we can do, we can also 3D print this box, you know, just to see how it really looks. So export 3D shell file, STL, export, and this is the file what we have created. I'm going to unpack this. This is the top and bottom part of the box. I'm going to place it inside of this software which I use for 3D printing. I will move this little bit. I will flip this, and okay, I will adjust the position, maybe like this. Okay, and maybe the first layer I would like to print a little bit slowly. 5. We would like to use support where the holes for the screw heads are, and let's have a look. Preview. Maybe I will adjust this. I use this technique so the corners of the box will not bend. So this is what I do. Okay, here is the support for the opening for the screw head. This is how it is going to be printed. Cool. We can save this to SD card and we can 3D print it. Here it is. And it fits perfectly. It looks good. So we can use it. Now, before sending files to production, be sure you run DRC checks again for the schematic and also for the PCB. Before you run the check for the PCB, be sure you rebuild all the polygon pores. There is shortcut Shift+B. You know, these are the copper areas. You would like to be sure they are rebuilt. So Shift-B. Now run DRC. Okay, there is no error. So there is no error in the schematic. There is no error in the PCB. And it means we can generate the files for PCB manufacturing. First, we are going to generate the files for the PCB manufacturing with the color silkscreen. So check this and generate the Gerber files. These are the files which are used for the PCB manufacturing. This is the zip file which we generated. I'm going to call it with color. And let's go inside. These are all the files which are needed to manufacture this PCB. These are the files for the color. So I'm going to copy all these standard files and we are going to double check them. I'm going to copy them here inside together with the drill files. I'm going to copy them inside of this directory. I didn't copy these color files because normally you can't really view them. And I'm going to use free Gerber viewer. So I use this ViewMate. It is free. You can install it. You can download it and install it. This is how it looks. Then go to File, Import Gerbers. I'm going to find where the files are located. So I'm just going to copy the path and I'm going to paste it here. Okay. And I'm going to select all the Gerber files. So press Shift, hold it down, left click. These are all the files which are going to be used to do PCB manufacturing. These are the bottom layers. This is just documentation. And these are the top layers. Top layer, top mask, top silkscreen. And you can see there is no picture because the information about the color picture is in these two files, which we didn't open because this viewmate can open it. Okay, everything looks okay. Cool. But as I said, normally you may not be able to print this colored board. So what we are going to do, I'm going to actually delete this picture, and I'm going to show you how you can do it without this colored picture. We will do it black and white. So I'm going to import the picture again, but this time I'm not going to check this. So it's going to be just black, or the color of the silkscreen. I'm going to change the size, place it on the board again. We would like to place it on the top silkscreen layer, don't forget. Okay, and I'm going to place it here. Okay, so this kind of PCB can be manufactured everywhere. The colored PCB right now, it can only be manufactured in JLCPCB in China. So that's why I'm showing you how to manufacture this one, because this is what you will be probably manufacturing. Don't forget to check the DRC. Everything seems to be fine. Save. Double check the 3D view. Let's hide the box. Okay, so this is how it looks. You can try different colors if you like. In the white and black. This time I'm not going to check this. So this is no color, export Gerber files. This is the zip file which was created. Inside there are the files to manufacture this standard PCB. Again, I'm going to unpack these files and we are going to double check them, okay? Because these are the files which we will use for PCB manufacturing. New, import Gerber. So go inside of the no color directory, select all the Gerbers. Don't select the drill files. We will check them later. This looks okay. Okay. These are the top. And now watch this. This is the top silkscreen, and now you can see there is the picture which we imported. Select layer 11 and import drill files. So select these two, import, disable these, and have a look what is inside of the drill files. So these are showing where the holes are on our PCB. Now go to export, bill of material. This is the file which will have information about the components. Be sure this is checked because we don't want to include the mounting holes in our BOM, bill of material. And also here you can maybe check the layer information, and you can use the same settings what I have here. Export BOM. Let's have a look what was created. So this is the file. I'm going to open it. Just double click. And as I said, you can see there are all the components which are used on our board. So the capacitors, connectors, this is the quantity, these are the designators, and these are the numbers for LCSC parts. Okay, export pick and place file. This is the last file what we need to export. This is the file with information about the position of the components. Again, you can use the same settings what I have. You can add the information about the BOM. And this is the file which was generated when we open it. So here are all the components. This is the position on our board. And this is the information if to add these components to BOM. So here are the mounting holes. I'm going to delete them from the list because they are not like real components. I'm going to save this as the top assembly. And this is the file which we will use to assemble our board. Order PCB and upload the Gerber files. So if you would like to upload the color Gerber files, you can do it, but it has to be supported. I'm going to upload these no color Gerber files. Here you can very easily check how they look. Everything seems to be fine. And I'm going to change some of the parameters. So we would like to have white PCBs with black silkscreen. Watch what's going to happen when I change this to ENIC. ENIC is the gold surface, so we have a nice gold logo. It's a little bit more expensive. We don't want to have the order number. It's kind of ugly, $19. We would like to do also assembly on the top side for 5 pieces. Okay, confirm part placement and leave everything default. Confirm. Next. We would like to add the bill of material. So select the BOM file, click on open. This is the pick and place file. So this is the top assembly without the mounting holes. And if everything is okay, then we should be able to see, oh, there is one part which is not available. This is the output connector, but it's okay. Everything else can be fitted by JLCPCB. This one we will just buy it separately. So go to next. Do not place the unselected part. That's the missing connector. Here you can double check the component placement. But from my experience, you can just click on next. If there is something wrong, they will always send you email because we ask them to confirm the placement. Here are the prices. So I know for this PCB assembly, the price seems to be high, but because you can fit all these components manually. But I wanted to show in this video how you can do it for any board. And now we are going to order also the box. So I'm going to click here. I'm going to be sure you are in 3D printing. I'm going to add the 3D files, top and bottom of our box. Just select both of them, use Control or Select or Shift. These are different technologies what can be used, and these are different materials for 3D printing. When you hover cursor over the material, you can see some information. Let's use this one. So I'm going to select it, black and surface finish, okay. This is for the top part, and use the same material also for the bottom part of the box. And I would like to print more of them. So let's print another one, but from different material. I'm just curious, it's not very expensive. So use this one. This is transparent. And use transparent material also for the bottom part of the box. It's again $9. That's nothing. So let's try different material. Different technology. This this color printing, this looks really cool. So let's try this, but they need different files. Let's go back to our board and let's have a look if we can generate this file. We can, yeah, obj. So I'm going to rename this, export. Okay, this is the file what was generated. I'm going to unpack top and bottom. I'm going to copy it here, go back to the website and add these two files, open, and select the color printing. This one is more expensive, much more expensive. What else we would like to try? Metal printing. Okay, so here I'm going to select metal printing, and what else we could try? This one. No, we don't want to use this one. This one. Okay, we can use also this one. So this is the last technology and material what we can try. Okay, so this is the bottom and top part for this nylon. This is for the color printing. This is the metal printing, transparent printing, and black box. I'm curious. I'm really curious how they will look. It's not very expensive, so this is cool. Okay, we have to fill out this information. I forgot. This is the information which will be on the invoice. When this goes through customs, so ideally you would like to put here something what makes sense. You know, when they ship these boxes and they need to go through customs, then this information or this description is on the invoice. So I'm going to just put here like box. Almost done. Okay. And one more. Okay, double check everything. So box, box, box. Okay, okay. Okay, save to cart. I'm curious now. So this is everything what we would like to order for 3D printing. This is our board, and this is all. So I'm going to. Okay, it looks like we have to order the boards and 3D printing separately. So first I'm going to order the boards. Okay, just continue. Have a look at the price. When you use different shipping method, the price is changing a little bit. I just use FedEx or DHL. Usually, it's up to you. Continue. Pay. Okay, normally I use PayPal, and if there are coupons available, you can use them. You will get discount and just pay. Okay, so the boards are ordered. Now let's order the boxes. Again, checkout. Continue. Continue. Submit order. So, okay. Okay, so they will send me an email. everything is under review right now. Let's go back to our project and let's order the missing connector, this one. So I'm going to copy the manufacturer part number, and usually I use Farnell, but you can use the component supplier which you normally use. I'm going to switch this to English so everyone can understand, and I'm going to search for this connector. They have two of them, cool, black and green one, so I'm going to have a look. It looks like the same connector, just the black one, so I'm going to order 5 of these, and also I'm going to order 5 of these. Yeah, they look correct. Okay, let's buy them. I've got the emails about the PCB and box production, so we have to confirm the placement. Click here and double check if the placement what they suggested is okay. So this is the corrected placement. Everything seems to be fine. This is the original wrong placement. This is the correct one. So okay, yes, go ahead with the production, and it's okay. Now the second email is about the box. They can't print the color one. Okay, because I didn't send the 3MF file, so I'm going to just send them email like cancel the 3D printing of the color box. Okay, so the mock color box, it was cancelled, and the other boxes, they are all approved. Okay, so we can pay this. Pay. In production, perfect. Now, let's wait. This is, by the way, the next tutorial what I'm working on. Once you receive your boxes, this is how it is going to look. So this is the standard one. You can see the silkscreen is one color, black color, but this one is the one with the color silkscreen. Beautiful. Remove the panel. And this is how the board looks. Now, you will receive also second box with the enclosure. So this is the metal one. It may need a little bit of adjustment. Then this is one of the boxes. This has some kind of structure. This one is black one again, but this is really nice. This is very nice. I like this one. Nice surface. Oh, this is the transparent one. Wow, this is cool. This is really cool. I like it a lot. Now, when we have a closer look on the PCB, you can see all the components and everything what we created. Double check if everything is soldered correctly. Double check the components. This is the bottom side of the board. Okay, you can see the nice gold logo. Perfect. We need to solder down the missing connector, so I'm going to do it. Clean the PCB. This is how it looks. Before measurement, tie the screws so the measurement is accurate. Watch the LED and it works. Okay, I'm going to measure the output voltage, plus minus 5 volts, perfect. Measure also the voltage on these CC pins, and this one is 0.4 volt. It means the standard output current up to 0.5, and this one is the upper charger. So I'm going to connect this, and let's compare the results. 5 volts, and this one is 1.6 volts, so it means this can deliver up to 3 amps. I'm going to place the board inside of the box. This is the transparent filament, which I'm going to fill inside of this hole, and you will see how nicely it will bring the light from the LED to the top of the box. I'm going to screw top and bottom part of the box together. So these are the M2.5 screws. Okay, now I connected the output from our power supply to the resistor load. I connected the DVM. This one is showing the voltage, and also I have this second DVM which is going to measure the current. Watch the LED. Nice, it's green, and 5 volts is on the output. And now I'm going to measure the current through the load. Watch how many amps will go through this. 2.5. Okay, I tested only 2.5 amps because I don't have the resistors to generate 3 amps. Everything works perfectly fine. And this is the transparent box. I included it in the video because I love it. It looks so nice. The PCB with the colored silkscreen and the transparent box. It's so cool. And that's it. That's everything for this tutorial. I really hope you design and build your own board and it's working. If yes, fantastic job. Well done. Now, you know everything important to start designing your own projects. If you would like to learn more about electronics, check out our online courses. You can find their courses about KeyCut, Altium, Cadence. There are courses for beginners and also for professionals about designing boards, PCB layout, EMC testing, measuring, and more. Just go to fedevel.com. Please don't forget to leave your comments and let me know if you like this tutorial. Thank you very much for watching and see you next time. Bye.